So the nature of the compound. So the mercaptans are the family of sulfur compounds responsible for the wine fault called reduction. Okay, the functional group is exactly the same as the varietal thiols. Okay, that I showed you earlier. So it's SH. And as the thiols, it is they are also the mercaptans, and thiols and mercaptans from the chemical standpoint are synonyms, okay? But you know, in the winemaking jargon, mercaptans, oh, they smell bad, but thiols, oh yeah, they smell very good. They're passion fruit, grapefruit. But from a chemical standpoint, thiols and mercaptans is exactly the same. They're quite oxidizable to disulfide, which intensity of the odor is lower. Okay, so higher sensory threshold. So the origin of the evolution of these compounds in the vineyard, they can come from the grape variety. For example, Syrah and Shiraz, they are very prone to develop reduction. Okay, sunlight, UV. Then in bold, lack of nitrogen. If during alcoholic fermentation there's not enough nitrogen, the yeast goes into the stress and it starts producing mercaptans, so sulfur compounds. Pesticides residues with sulfur and the molecule. Then in the cellar, pressing, yeast selection, sulfite addition, alcoholic fermentation management. There's 2 points here. One that I mentioned is the concentration of nitrogen, the EN, yeast assimilable nitrogen, but also the fermentation temperature. We're going to see that later. Lees management and photochemical agents like the lighter struck, which is common in the champagne and like some other sparkling wines. Okay, aging. What happens during aging? If we go through barrel aging, okay, here there's the example of a methane thiol. Barrel aging, you know that oak is permeable to oxygen, so oxygen gets into the barrel, oxidizes methane thiol to the corresponding disulfide. But what happens then when we're ready to bottle the wine? We add SO2, so the redox potential inside the bottle decreases. So we are in reducing conditions. So we go back from dimethyl disulfide back to methane thiol. Okay, and this has been well described by a study by Vicente Ferreira, the research group at Zaragoza. Okay, they've been monitoring the methane thiol during up to more than 500 days, so like more than 1.5 years, and you see that little by little the free and bound methane thiol increases. Okay, and so one of the explanations is this one. So prevention and treatment. How can we prevent the sorry, the reduction or wine fault? Nitrogen content, so good management of assimilable nitrogen during fermentation. Okay, so ideally we should have the EN between 150 and 350 milligrams per liter. Then aeration oxidation during the alcoholic fermentation or just at the end of alcoholic fermentation. Because the master juice and wine during fermentation induces the aeration, induce dissipation, oxidation of H2S, which is the precursor of all the other mercaptans. So temperature during alcoholic fermentation for the white wines is between 15 and 20, and for the reds is between 25 and 30. So beyond this temperatures, the yeast get the shock, and this may cause the hyperproduction of H2S, okay, in the wine. Then barrel aging and use of oak chips, it is positive because it can play like it can have a masking effect on the reduction of flavors. And now we're gonna talk about copper treatment.